So next item would be what I've showed you last time was actually a Graham condenser. So anyway, it is as I've said, there are a lot of condensers. But anyway, this one is the ordinary type of condenser wherein it has a solid tube inside, but still you can see the in and the out, or the out in of your coolant, usually water from the faucet, so that it would not cost you too much. So that's the use of your condenser, condensing vapor materials. So with the use of a um, of a uh, what do you call this, cooler materials like water from your faucet. So it goes here and then goes out, and then probably you can just pump to reciprocate that water so that it wouldn't be a waste. So this is the part wherein it catches the vapors from, let's say, from a Florence or from a boiling flask, wherein you evaporated something. Where is that flask? Here, boiling flask, and then you have a setup wherein that vapor would not come out except to be caught by this tip of your condenser. So when the vapor comes here, then you have a cooler material inside this. I mean, sometimes it's being wrapped with ice. That's also one option. And then when it comes contact with your cooler material, that hot vapor will now turn into liquid. And it will drip in this portion here. Maybe you have to put something here so that it will catch now the liquid or the condensed. So that's why this is condenser, because it condenses that vapor again to the liquid. Anyway, the details of this one, for example, for experimentation, is not included. So I am just demonstrating how these are used. So this is a common condenser, but this one is a Graham condenser. So you can see the difference is you have a corrugated inside tube. So what's the use of corrugated inside tube? Actually, the heat transfer actually is better for this one than the ordinary one. Why? Because that corrugation allows you for more contact of that colder material. That's why it's more curved. Okay? That is for efficient contact of your cooler material. For example, you have water inside. So that is your Graham condenser. But the use still is for condensing vapors into liquid part. So that is your Graham condenser. Next item is a graduated cylinder. I think this is one of the most common laboratory equipment, even in high school. As you can see, if you enter a laboratory, basically you can find this one, because this is, of course, it comes in sizes, and when we try physics, chemistry experiments, we measure usually tantamount liquid in a bigger amount. So this one can hold 100 ml. You can measure up to 100 ml. Of course, you can still measure 50, 60, 70. But if you're going to measure 25 ml from a graduated cylinder, so you'd better use the smaller size for this one, because again, the accuracy would matter really. For a 25, let's say you want to measure 20, let's say 15 ml. So you'd better use the 25 ml rather than this one, because the accuracy would be better. The accuracy would be better. Why? Because the calibration, as you can see, for the 25 ml is much smaller than this bigger size graduated cylinder. So again, graduated cylinders are used to measure liquid, but you have to take note of the calibration. So for bigger sizes, you need bigger sizes. For most smaller sizes volume, you need smaller volume graduated cylinders. And for smaller volume, for example, you want to measure 1 ml. So you should not use a graduated cylinder for that. But again, the answer would now be a pipette or probably a burette. Okay? So that is measuring volume accurately. So you don't measure volume with flask or anything. Again, or beaker. So it just holds liquid. So this one is used for measuring volume. But you have to pay attention with the calibration. For 100 ml, it should be 100 ml. Where's the video? I think Okay, next